Greetings everyone, and welcome back to the hood. Can we make working again? This time on the bench is this Carver magnetic field power amplifier, model PM-1.5, low feedback, high headroom power amplifier. I have the front removed already. Power sequencer, clipping eliminator. So yeah, this is a interesting little amplifier here. I did clean a little bit of dirt out already. Let's see what the problem is here. The lid. It says needs fuse to test, slow blow 12. Front aluminum panel. It's been in a rack. Have to be careful not to bend these pins. So yeah, let me dig up a fuse for this thing. Okay, I dug up a 12 amp fuse. I believe it's a slow blow. Not a good sign when the main fuse might have blown. I assume that's why it was missing. So I have it hooked up to a 100 watt bulb limiter here for the first power up. I can't do this holding the camera. Hang on. Okay, let's see what happens. Ah. It's got a noisy little fan in it. It's buzzy. There's a switch back here. It says quiet, so I guess it slows the fan down. So that's encouraging. It's not drawing a whole lot of current. The bulb, it's a 100 watt bulb, and it's it's kind of dim, maybe like 30-40 watts. So dare I hook some speakers up? I'll check, make sure there's no voltage on the outputs. I don't want to blow up my speakers. Okay, it's plugged directly into the line, hooked up my speakers. Had to dig around to find a proper audio connection for these PA type amps. I can only do one channel at a time. I don't have enough for stereo. So, whoa, it makes the lights flicker. The fan's slower. I guess when it's on the bulb limiter, it thinks it's hotter or something. I did put a drop of oil in the bearings of the fan. Blew out the dust before I started here. Let's see what happens. I have the YouTube safe music queued up. Didn't hear any sound from the speaker. That's bad or good. Let's see, we're in the right channel. Whoa. Actually works. pretty loud. I don't know what the wattage is on this thing, but it looks pretty high with, you got 10 transistors on each channel. So yeah, I'm not gonna really crank it. Okay, let's try the other channel. Well, I think we got lucky here. Doesn't seem to be anything wrong with this. I'm getting clean signal out of both sides. Boy, that's got a lot of hum, doesn't it? A lot of buzz. That's the magnetic field power amplifier action going on there. Pretty interesting. This has multiple supply rails. So if I probe here on the collector, ground to collector, 33 volts. Let's try moving over here. Negative 33. So this side's the negative side of the amp. This must be the positive side. So negative 33 on the innermost transistors. 70 volts. Let's try the next transistor out. 70 volts. Next transistor out from that. Ooh boy, look at that. 114 volts. Next transistor out, the final one. Another 114 volts. Plus and minus 114 volts. What is that? 228 volts across the rails. Wow, that is steep. So it looks like there's 2 transistors in parallel on the high rail, 2 in parallel on the mid, and just 1 on the low rail. So it's like a class G type arrangement. What happened? I'm getting buzz. I think my music player went to sleep and the output goes high impedance. Yep, that's what it was. No problem. Kind of scared me there for a minute. But yeah, class G arrangement, so it only turns on the transistors it needs for the amount of output signal. That allows it to run cooler and spread the load across the transistors. So the higher the signal, the more transistors are used. That's why it doesn't have a huge heat sink. The whole bottom of it's a aluminum plate, and it has the fan, so it helps cool the thing off, but doesn't need near as much heat sinking as a regular amp with such rails would require. But yeah, this thing, I have to look it up. It obviously is capable of some serious output power. Greetings everyone, and oh wait a minute. I'm in the middle of a video. Well, it's been a few days. Memorial weekend came up and I had some other things to do, so I haven't been at the bench. So, if I remember correctly, I was testing this thing and both channels were working. Maybe it was just a pop fuse. I noticed these things, when you turn them on, it makes the lights flicker. Probably after a lot of cycling on that slow blow fuse, it probably just gave up. So there's really nothing wrong, hopefully. But I still need to do some tests. What I want to do is hook up a powerful load. I mean, a load that can handle high wattage. And I don't really have any components to do that, power resistors. But I do have this old electric heater. It's 10 ohms though, but yeah, that's near enough just to use it. I have these. These are 100 watts. They can take some overload for a little bit. But this amp is, if I remember correctly, it's 450 watts per channel into 8 ohms. And yeah, if I go too high, it just might pop the coil inside there. I don't want to ruin those. So I'll just have to use that. I can only do one channel, though. Test one channel at a time. I can't do both channels driven because I don't have, the two 1/4 inch connectors for the 1/4 inch jacks back there. And yeah, just one load. So I was reading up on this amp, and I guess that, and some people said in the comments that some bands like to take these out on tour. Pink Floyd. I don't know this particular model, but they said Carver amps. So yeah, I don't know if it's true or not. You hear stories. To me, if these are truly reliable, I would like, if I was a roadie, I would take them out because they're not as heavy as the big PA amps. These are like 21 pounds. I mean, they do feel pretty heavy for its size. If you compare it to a piece of home equipment of this size, it does feel heavy. But it's a lot lighter than some of those larger PA amps that those things weigh 40, 50 pounds or more. So you imagine a rack of these things compared to those. A couple of racks weigh as much as a small car. So yeah, plus they're skinnier. They're much more narrow, and they would need to put more of them in a set of racks. I don't know though. I'm not experienced in that. I don't know if these are good or bad. I don't have a horse in that race, so like I say, these were given to me. They were pretty much considered junk, going to be tossed, and I have an opportunity to tinker with them. Well, I did clean the front up a little bit. Let's get some light on that maybe. And it cleaned up fairly nice. It's a shame though that the top's scratched up. You could give it the rattle can treatment. Take it off and sand it and give it the rattle can treatment. Unfortunately, it is missing some screws from the side, but I didn't have anything that fits. But anyway, I want to test this thing out, see how it can do. If I didn't mention it before, I forgot where I left off, but before I put the lid on, I went through and tested all the electrolytic caps, power supply on the board. There's a couple up front and near the bottom here I couldn't get to easy enough, but those are for the meters. If the meters are working, then it's fine. But yeah, tested it out, and I guess I yacked enough. Let's finalize this thing. I want to test. Like I say, it has 3 rails. It has the low, medium, and high rails that kick in as it needs more voltage for the output swing. And it is working the low rails, but it does have the voltages for the other rails. But I want to hook it up to a load and to the scope and see if we get all the rails going there and crank it all the way up into clipping. These amps are really made for music dynamics. They're not really made for continuous sine waves at maximum power, or at least for very long. The transformer's smaller inside these things. Okay, the magnetic field thing is on. You can hear it buzz. I think it's noisy. Coil is hooked up. I have my power supply. bumping the thing. There's clipping. We cranked her into clipping. And we got the lights are working. See, it's clipping there, it goes into clipping. So let's get a measurement here. Let me turn off the light there so I can feel the heat coming off that coil. Yeah, this amp has got some power to it. Okay, can't find my regular calculator, but I saw 66.7 volts RMS squared divided by the 10 ohm resistance, and we get 444 watts. So it probably measures a little high. Again, this is 10 ohms, so it wouldn't be as high as it would be with 8 ohms. And that I'm running only one channel, not both channels driven. So that's the output power, very good, and everything looks normal. Let's see, I had to have more waveforms on the screen to, there we go. I'll crank it up again. Hang on here. I don't have room to set everything up. I'm not going to do distortion test. It looks like a nice sine wave though. But I don't see any oscillations or anything. So the amplifier's working quite well. At least the right channel. Let's check the left channel. Okay, moved over to the left channel. And clipping. So that meter's working, and I already measured the scope readout here, and it's same power. Let's take a look at the waveform here. I don't see any, little bit of hang on, but you know, that's par for the course, but no oscillations or anything. Yeah. I just can't believe it. They were going to pitch this thing in the trash. All it needed was a cheap little fuse, and it works fine. You know, this thing, 450 watts per channel to 8 ohms. I can't remember if it handles, I think it does handle 4 ohm loads, like 600 watts per channel into 4 ohm loads. Bridged, if I remember correctly, it's 1200 watts, 8 ohms bridged. So yeah, this thing is just, it's a heck of a little amp as far as power goes. Well, whether you like these things or not, you know, that's your choice, but it works. All I can say, the thing works just fine. And they're going to throw it away. But there you go. I guess there's not much more to say. Snickers has something to say. Are you hungry? No, yeah, he's hungry. Yeah, he wants food. He don't care about no stupid amp. He wants food. No, Snickers. Well, that's going to do it for this one. Really appreciate you guys watching. Appreciate the Patreon support. And we'll see you on the next one.